Hi, welcome to this video on functions. Today we're going to look at some worked examples so that we can understand functions a little bit better. But before we look at the worked examples, I think it's good to revise very quickly just what went on in the last video. The main points of the last video is that we should think of functions as machines, something that works rather simply. And what it does is, you put in an input and then you get an output. Okay. And in mathematics, most of the time, our input is represented by the letter x, and the respective output will be f of x. Okay, and let's say that if you found out, right, x is a fixed value like 2, right? So if you put 2 in, the output you will get is f of 2. Okay, so now let's look at the example over here. In this example, it says that the function is defined f of x is equals to x squared plus 2x plus 1. And in part A, we have to find out what is f of negative 1. Okay, so if you see a negative 1 inside the bracket, it means that we are going to take negative 1 as the input, and we want to find out what output is. So let's write that down, f of negative 1. And what happens is I'm going to do a substitution. Every time I see the letter x, I'm going to substitute it with negative 1. So here you go. X squared becomes negative 1 squared. And then plus 2x plus 2 times of negative 1. And then plus 1. You realize that this 1 over here does not depend on x, right? It will always be 1. And that's why we call it a constant. Doesn't change. Doesn't matter what x is. It will always be 1. It's a constant. And now let's work this out. We can simplify this, right? And negative 1 squared, that's going to be a positive 1. 2 times of negative 1, that's a negative 2. So we're going to minus 2 and then add our constant 1. So 1 minus 2 plus 1, you should be able to reason out that is equal to 0. And we've just worked out part A. F of negative 1 is equals to 0. Okay, now let's look at the part B. Part B, we want to find out what's f of 0. Okay, so we're going to substitute x equals to 0, and this is one of the best substitutions you can make. It's really easy because 0 times any number is just going to be 0. So this is going to be 0 squared, 0, 2 times 0, 0, then plus 1. So what is left is only just the plus 1, isn't it? And what you have, f of 0 is equals to 1. Now let's look at part C. Let's do f of negative 2. So f of negative 2, we're going to substitute negative 2 in. There you go. And now we can work out each individual term. Negative 2 squared is going to give us a positive 4. And 2 times of negative 2 is going to be a negative 4. And then we add 1. And this will give us 4 minus 4 is 0 plus 1. That's going to give us 1. Okay. And I think I have a bit of space over here. Let's make use of this space here. And I'm going to do f of negative 3 here. F of negative 3 is equals to negative 3 squared plus 2 times of negative 3 plus our constant. Negative 3 squared very quickly is just 9. This is going to be a negative 6. This is going to be a positive 1. And 9 minus 6 is 3. 3 plus 1 is 4. Okay. And then I still have to do f of 1, and I'm going to do it here. F of 1 is going to be 1 squared plus 2 times of 1 plus our constant. And this will give us 1 times 1, that's 1. 2 times 1 is 2, and plus 1. So that will give us 1 plus 2 plus 1, 4. Yeah. So I found out all 5 inputs. You can see we have 5 inputs, and I found all 5 outputs, right? For part D, the outputs of f of negative 3 and f of 1 is the same. That's 4. Okay, and what I like to do next is I want to represent all the inputs and outputs that we have worked out, or rather all the outputs that we worked out in a table form. Okay, and what I like to do also is I like to arrange. Okay, so the letter x is going to represent all my inputs. I'm going to put it in this row. The notation f of x is going to represent the outputs. I'm going to put it all in this row here. So instead of just putting in x values, following the order of the question, I'm going to put it in numerical order. I'm going to start with the lowest input. And looking at all the inputs here, you can see the lowest input is negative 3. So I'm going to start with that. This is going to be -3, and then -2, and then -1, and then 0, and then 1. Yeah, and then I'm going to fill in the respective outputs. For -3, f of -3 gives us 4. F of -2 gives us 1. And then f of -1 gives us 0. F of 0 gives us 1. And f of 1 gives us 4. Okay, and what you see here, if you look at the outputs, there's some kind of symmetry going on, right? On the outer pair of outputs, you have 4, 4 and 4 here. And as we move inwards, you see 1 and 1 here. And then right at the center, we have 0. And we can do a quick sketch of the graph. Let's do this. This is going to be, say, x against f of x. Yeah. So at -1, let's start from the center of symmetry. -1 is somewhere around here, and the output is going to be 0. Okay. And let's look at, say, when x is -2. When the input is -2, yeah, the output is going to be 1. So somewhere around here. Okay. And then if I move to -3, and x equals to -3. Oh, this sketch is pretty poor. Huh? It's a bit crooked. Sorry about that. When the input is -3, the output is going to be 4, something here, like that. And then you see some sort of symmetry going on. So on the other side, when x is equals to 0, output is 1. Yeah, so this is symmetrical to this point. And when x is equals to 1, the output is 4, symmetrical to this point. And if you try to join the points with a smooth curve, sorry, my drawing is not smooth at all, right? Sorry, really sorry about that. Huh? What you get is a parabola, right? A curve. It looks like this. Yeah. So always label your graphs. This is f of x equals to x squared plus 2x plus 1. All right. Let's look at another example, just to be sure how functions work. Okay. So over here we have a new function. Right, this function is defined to be negative bracket x minus 1 everything squared plus 5. And some of you might recognize this form. This form is known as completing the square form. Okay, and for part A, we want to find out what's f of 1. F of 1 is very simple. We just want to substitute x equals to 1. Every time we see an x, we change it to 1. And this is what you're going to get. Okay, next, after writing this down, you can look at what's in the brackets. Because the constant is just a 5, let's try and work what this is. And inside the bracket, you have 1 minus 1, and that's going to be 0. Yeah, 0 is an excellent number. 0 squared, right? 0 times 0 is 0. And then we multiply by the negative sign. Doesn't really matter. It's still 0. And what we end up with is a 5. Because this whole thing is 0. 0 plus 5 equals to 5. Yeah. This is equals to 5. Oops. Let me see. Get a pen. This is 5. All right. Moving on. Let's do f of 0. Okay. If you do the substitution, this is what you get. Again, let's try and work out what this is. 0 minus 1 is going to be a negative 1. Negative 1 squared will be positive 1. And then we multiply by the negative sign outside the bracket, that'll be a negative 1. Yeah? So negative 1 plus 5 is going to be a positive 4. So we have a positive 4 for f of 0. Right? Next, we're going to look at f of 2. Right? If you do the substitution, this is what it looks like. Again, let's look inside the bracket. 2 minus 1 is going to be positive 1. Positive 1 squared is still positive 1. Then we multiply by the negative sign, that becomes a negative 1. So this is negative 1 plus 5. That is a positive 4. All right, and then let's look at f of 3. Right, f of 3 looks like this. Let's look inside the bracket. 3 minus 1 is 2. 2 squared is positive 4. Positive 4 times the negative sign outside becomes a negative 4. Negative 4 plus 5 is positive 1. Right? So we have positive 1 here. And then let's also do f of negative 1. This is what it looks like after you do the substitution. Looking inside the bracket, negative 1 minus 1. That's negative 2. Negative 2 squared is going to be positive 4. Positive 4 times the negative sign is going to be negative 4. So negative 4 plus 5 is going to be positive 1. So we found all 5 inputs and outputs. let's write them down in terms of a table, right? Again, this represents all the inputs, this represents all the outputs, and I want to arrange my inputs in numerical order. So looking at all my inputs, 1, 0, 2, 3, -1, let's start with the smallest, which is -1. And then as we go up, it becomes 0, 1, 2, and 3. Okay, and I'm going to fill in the respective output values. F of -1 is over here, that is 1. F of 0 is over here, that is 4. F of 1 is going to be 5. F of 2 is going to be 4. F of 3 is going to be 1. And then we can do a sketch, right? And you can see that the center of symmetry is going to be at x equals to 1. Yeah. Again, the symmetrical nature of this graph, the outputs are 1. If you move inwards, is 4, and then 5 in the center. So x equals to 1. We have somewhere up here, maybe this is 5. Okay, and as we move, say, to the right, x equals to 2. We're going to get slightly lower, 4. And as I move one more to the right, x equals to 3, you get even lower, right? 1. Okay, and if you move, say, to the left of the center, when x equals to 0, that's going to be 4. This is symmetrical to this point, right? And as we move more to the left, then you get 1, which is symmetrical to this point. And if you join all the dots together, and I'm going to extrapolate the curve a bit, which means drawing the curve at points that are not there. Right, so it's going to look something like this, like a nice parabola. Hopefully this time it looks better. Yeah, I think it looks a bit better, still not so good. Okay, and then we label the graph. This is equals to this. Ran out of space, so there you go. Okay, so this is what we like to do with functions. We like to think of them as machines. We put in values, we substitute inputs inside here, and then we also do it correspondingly on the right hand side. And then we get fixed values, or rather values, and we like to plot them out in a table, which helps us to draw a graph. Okay, but why do we do all these things? What is the purpose of a graph? Why don't we just stop at a table? Right? The purpose of a graph is that it can tell you about points, or it can predict for you the outputs for inputs that you did not work out. So if you look at this example, I only put in 5 inputs and I got 5 outputs. But say if I'm interested in the output for, say, 1.5, yeah, this is 1.5, okay, I don't really have to do this whole substitution process. All I need to do is read off my graph, right? This input will correspond to this output. Yeah, does that make sense? Okay, so if I, say, want to find out what is 2.5, without actually substituting, I can use the graph and work out, oh, this is the output for 2.5. So what you see is that the graph is a very useful tool. We don't have to keep on doing this substitution because it's tedious. It does take up a bit of time. And also, the benefit of a graph is that at one glance, you can tell the characteristic of this function, this machine, right? How does it increase? How does it decrease? Does it always increase? Does it always decrease? Right? One good characteristic that we can tell from this graph is that the output does not always increase when I increase my input. Say, for example, if I want to increase my input to, say, 5, say this is x equals to 5, you would think that, oh, x equals to 5, the input is much bigger than, say, 1. Yes, I'm putting in big numbers compared to, say, this. Maybe my output is big, but you can actually take a look at the graph and see that, no, the output actually is rather quite negative. So you can tell at one glance how this machine actually behaves when you put in different kinds of inputs and or outputs. Okay, so that's the end of this video. I hope you have a better idea of how functions work. Stay tuned for the next video where we talk about roots. And until then, I'll catch you on the flip-flop.